In this lesson, we'll be discussing the rules of logarithms. First, what is logarithm? So we say logarithm is the power to which a base must be raised in order to get a particular number. So we say logarithm answers the question, to what power must a base be raised to produce a given number? In simple terms, we say logarithm is basically the inverse operation of exponentiation. What do we mean? For example, let's say we have an integral expression. Let's say a raised to power x is given a particular number. So transforming this into logarithm means the logarithm of this number n to a base of a is giving us what? Is giving us x. So in this, it means this a here is our base. This n is the number, and the x here is the power or the index or the exponent. Okay, so the logarithm of this number is the power to which the base is raised to get this number. So that is where the definition of logarithm comes from. So the logarithm of a number is the power to which a base a is raised to give the number. That is, the logarithm of a number n is x if the base of that logarithm is base what? Is a. So that's the basic idea of what logarithm is. Okay, now let's look at a typical example. For example, we say 10 to the power of 2 is going to give us 100. The consequence of this, transforming this from this exponential form to logarithmic form, means the logarithm of 100 is what? Is 2 if the base is base 10. Okay, another example. Let's say we have 2 to the power of 5 is 32. What does that mean? It means the logarithm of 32 to the base of 2 is going to give us what? It's going to give 5. Okay, so you can try this. Let's say we have 5 to the power of 3 is 125. Now try to transform this into the logarithmic form yourself. And this is what you are going to get. That is the logarithm of 125 to the base of 5 is going to be what? It's going to be 3. This is the basic idea of what? Of logarithm. So we say, in simple terms, logarithm is the inverse of what? Of operation of exponentiation. Now, the next thing is, now let's look at the various rules of logarithm, or the properties of logarithm, or you call it the laws of logarithm. Now, the first rule of logarithm, can call it the product rule. So let's say rule 1. Rule 1 is the product rule. Okay, it says the logarithm of a number. Let's say the logarithm of a number m added to the logarithm of a number n. Let's say they are equally on the same base. They have the same base. It's the same as the logarithm of m multiplied by n. Okay, a typical example of this is, let's say an example of this is the logarithm of 2 to base 10 plus the logarithm of 5 to base 10 is going to give us the logarithm of 2 multiplied by 5 to base 10, which is the same as logarithm of 10 to base 10. Because this can simplify to give 1, we are going to look at this as part of the rules. The logarithm of a number to the same base is going to give us 1. Now, the second rule, rule 2, is the quotient rule. The quotient rule. Okay, it is the logarithm of a number minus the logarithm of another number to the same base is going to give us the logarithm of the number divided by the first number divided by the second number to the same base. Okay? A similar example of this, let's just look at the typical example. Let's say we have the logarithm of 100 to base 10 minus the logarithm of, let's say 10 to base 10. Okay, just for the sake of an example, then this is going to give us logarithm of 100 divided by 10 to base 10. And upon simplification, you see that this is logarithm of 10 to base 10, right? Now, the third rule is, let's call it as rule 3, the power rule or the power law. The power rule. Okay, that is, if you have the logarithm of a number to an exponent, let's say exponent k and base a, this can be rewritten as k logarithm of m to base a. This is called the what? It's called the power rule. Let's just look at a typical, very simple typical example. Let's say logarithm of logarithm to base 7 of 49. Logarithm of to base 7 of 49 can be written as logarithm of 7 to the power of 2, 7, which is 2 logarithm of 7 to 7, 7 to base 7, which will give us 2 times 1, which is 2. Okay, because logarithm of a number to the same base is going to give us 1. Okay. Now, another rule, let's call that one rule number 4, which is the one we have been applying so far. Let's just name it as a separate rule. That is logarithm of unity. Let's look at logarithm of unity first. Okay. Let's look at logarithm to the same base first. Logarithm of number to the same base. We have been applying this, so let's just take it as a property on its own. That is logarithm, let's say logarithm of a number m to the same base m is going to give us 1. Okay? And this makes sense in the sense that from the definition of logarithm, you have said it earlier that if I have, let's say I have 10 to the power of 1, 10 to the power of 1 is still going to give me 10, right? If this is transformed, if you observe this, you see that the power to which 10 is going to be raised to get 10 is still 1. Okay, so if this is transformed into logarithmic form, then we are going to have the logarithm of 10 to that same base 10 to be that index power 1 here. Okay, good. So that is the fourth property. Now let's take logarithm of unity as the fifth. Logarithm of unity, that's rule 5 now. Logarithm of unity, log of unity. Okay, then the logarithm of a number, let's say the logarithm of 1 to any base is 0. Okay, though it is a condition that a is not 0. Okay, that is, if I have, for example, logarithm of 1 to base 5 is going to give us 0. Logarithm of any number of 1 to any base at all is going to give us 0. And also, we will see that this can be written as 1 is the same as 5 to the power of 0. Okay, from the laws of indices. And we know that a number raised to the power of 0 will give 1 on the condition that that number is not what? It's not 0. So that's what we are talking about here. This is the same as saying a to the power of 0 is going to give us 1. Right? But the condition still remains that what? A cannot be what? 0, because 0 raised to the power of 0 is not necessarily 1. Okay? So A has to be greater than 1. A must not be 1. All right? Now, let's move on to the next rule, rule number 6. Of course, we'll still look at simplification examples as a separate video on how to apply all these laws. We use them to solve simple and complex problems, respectively. So let's look at the inverse rule. The inverse rule. The inverse rule of logarithm is if you have a number a raised to the power of a logarithm, let's say raised to the power of logarithm of m to that same base a. This is the same as saying we have m. Okay. Okay. So logarithm of a number a, logarithm of a to the power of logarithm of m to base a is still going to give us what? It's still going to give us m. What this means is if I have, for example, let's say I have 10 to the power of logarithm of, let's say 100 to the power of 10, to the base of 10, is still going to give us what? It's still going to give us 100. Okay. And if we demystify this based on the previous theorems we have learned, we will see that we're going to have log 10 logarithm. 100 can be written as 10 to the power of 2 to the base of 10 equals to 100. This can be written as, using the power law, of 10 as 2 logarithm of 10 to base 10 equals to 100. And logarithm of 10 to base 10 is 1. Then it means this simplifies to give 10 to the power of 2, which is going to give us what? 100. So since this left-hand side is simplified to give the right answer, we could see that this theorem, inverse rule, actually holds. So a to the power of logarithm of a number to that same base a will give us, will also give us m. Now, let's look at another theorem. Logarithm, let's call this one the reciprocal law. That should be rule, this should be rule 7. Rule 7, that's reciprocal law. Reciprocal law. Reciprocal law. So this is the logarithm of inverse of a number to a base a, to another base a, is the same as negative logarithm of m to base a. Okay, this is called the reciprocal law. Now, of course, this one we can also simplify this to prove that it is actually going to be this. Remember the quotient rule. The quotient rule is, you will see that 1 over m is a division, which is like a quotient. So we can simplify this as the logarithm of 1 to base a minus the logarithm of m to base a, using the quotient rule, the second rule that we discussed. Okay, and from here we know that logarithm of unity is what? Logarithm of unity is 0, and 0 minus logarithm of m to base a is still going to give us what? Logarithm of m to base a, or negative of logarithm of m to base a. So this is, obviously, this is going to be correct. So logarithm of a reciprocal is always the negative of that logarithm. Let's look at a typical example. For example, if we say what is logarithm of 1 over 10 to base 10. Okay, you agree that this will be exactly the same as negative logarithm of 10 to base 10. Okay, let's say we have logarithm of 35 to base 5. Okay, sorry, logarithm of 1 over 35, logarithm of 1 over 35 to base 5. See that this is the same thing as negative logarithm of 35 to base 5. Okay, so we are still going to see further examples that we will use combinations of these laws, because typically most questions comes requiring you to use combination of all these laws to arrive at a simplified answer. Okay, so let's look at the next law. Let's look at the equality law. Okay, call that one rule number 8, not 9. Rule number 8. Rule number 8. So for rule number 8, we call this one the equality rule. Equality rule. Okay. Sometimes you might be simplifying a logarithmic equation, and eventually you have simplified up to a point where you have something like logarithm of m equals to logarithm of n, and both of them are to the same base. In that context, we're going to say m and n will definitely be what? Will definitely be the same. So the next theorem, let's call that one theorem 9, okay, is the theorem we call the change of base. Change of base. Okay. Now, assuming we have, let's assume we have logarithm of m to a base a. Okay. This could be rewritten as logarithm to a new base b of m over logarithm to that new base b of a. Okay, just like we shared logarithm for both the number and the base. Okay, a typical example, let's say we have logarithm of 8 to base 10. Can be written as what? Logarithm of 8, let's say, to base 2 over logarithm of 10 to base 2. So this is called the change of base logarithm. It's commonly useful when you are dealing with logarithm that are not, you are doing logarithmic simplification that all the bases are not in the same base, and you to proceed, it is needed to change them to a common base. Then, especially when there are common terms that can eliminate, we'll see examples of application of logarithm of base. Now, before we wrap it up, there is another logarithmic rule that we can coin, though it is part of what we have already discussed, but we can also coin in a new property of logarithm from that. Let's just call that one rule 10. Now, this particular one, we are not going to call it any name. Let's just say we have logarithm of a number m to base, let's say base k, and we have a logarithm of number m to power k, sorry, and is so a base a with power, let's say n. Okay, this can be written as, of course, we know that the power log k goes to the back and becomes logarithm of m to a to the power of n. However, we can also take this n to the back such that we now have k. This n will now be the fractional part, the denominator, when taken to the back of the logarithm, then it becomes k over n of logarithm of m to base a. Okay, so this is also an important property that you need to watch out for. Let's just have a typical example of that. For example, let's say we have logarithm of 1000 to 100 to base 100. In this case, we could rewrite 1000 as logarithm of 10 to the power of 3, right? And we could write 100 also as logarithm of 10 to the power of 2. Then 3 can go to the back, 2 can go to the back as a fraction. Then we have logarithm of 10 to base 10, which is the same as what? 3 over 2 or 1.5. Okay, so these are some of the basic properties of logarithm. So in the subsequent video, we're going to see how to apply some of this logarithm, how these logarithms rule, how to apply them how to use them in solving simple logarithmic problems, simplifications specifically. And sometimes we could have logarithmic equations that also leads to other forms of other equations. It will start as logarithm. Eventually, after simplification, it could result into simple equation, quadratic equation, and so on. So I'm going to make separate videos where we solve several problems on applying the various rules of logarithm.